Today in this session, we will be studying about the determination of electrical conductivity of water. The test procedure is given in IS 3025 part 14, IS 3025 part 14. Part 14, the code was published in year 1984 and reaffirmed in year 2002. The principle behind this test is that electrical conductivity is a measure of water ability to conduct electricity into it. Water containing dissolved salts of calcium, manganese, sulfate, chloride, etc. conduct electricity into it. More the concentration of iron, more the electrical conductivity is. When we immerse two electrodes into the water and apply the voltage, iron moves between the electrodes and generate electricity. This electricity is measured by the conductivity meter and displayed in the screen in the micro Siemens per centimeter. Measurement is electrical current measurement is measured in micro Siemens per centimeter or millisiemens per centimeter. Electrical conductivity is the measure of water ability to conduct electric current. Water containing dissolved salts such as sodium, calcium, magnesium, chloride, sulfate, etc. conduct electricity. The higher the concentration of dissolved ions, the higher the conductivity. When a voltage is applied in the electrodes immersed in the water, ion moves and generate the electricity. This electric current is measured by the conductivity meter and displayed in unit microsiemens per centimeter or millisiemens per, per centimeter. So this is how the principle of electrical conductivity works. We need the apparatus for measuring the electrical conductivity of water. We need the conductivity meter. It can be digital. Then we need electrode having cathode and anode. This will measure the electrical conductivity of water. Then we need beaker of 250 ml. We also need the measuring cylinder. We need the stirrer for solution, for proper mixing of solution. Then we need the distilled water, tissue paper, and the wash water. Apart from this, we also require a thermostatically controlled water bath which can maintain the temperature of standard solution or temperature of water sample obtained from the field at 25 degrees centigrade plus minus 0.5 degrees centigrade. So we prepare the standard potassium chloride solution at 25 degrees centigrade. It will give the 0.01 molarity of KCl at 25 degrees centigrade. In this, we take 745.6 milligram of anhydrous KCl, immerse in the 500 ml of water, shake it well before, then make it 1 liter. This 1 liter of solution will give the molarity of 0.01 mole per liter, and it will have the electrical conductivity of 1413 microsiemens per centimeter. So in step 1, we clean rinse the volumetric flask with the distilled water. Then we measure anhydrous KCl 0.7456 gram and then take it in volumetric flask, add 500 ml of water, and then shake it well, then add more water to make it 1 liter. This 1 liter of solution with the KCl of 0.7456 gram will give the solution of 0.01 mole per liter. 0.01 mole per liter. The electrical conductivity of this water will be 1413 microsiemens per centimeter. We can also check with the calculation the potassium chloride. The potassium is 39.10 gram per mole, and we know that 1 mole is 6.022 into 10 to the power 23 particles. This particles on weight, it will give 39.10 per mole and 35.45 per mole gram per mole is chloride. Adding both get the KCl per mole is 74.55 and amount taken in dilution 0.7456 gram per liter. And to know the molarity of this solution, we divide this 0.7456 gram per liter to the 7455 gram per mole. then we get the gram per mole, we get the molarity in 0.01 gram, 0.01 mole per 0.01 mole per liter, 0.01 mole, 0.01 mole per per liter the molarity of the solution. Then with the help of this standard solution, we can make different molarity of the solution as per the requirement. Then conductivity of different concentration of the KCl prepared from the standard solution. When we prepare 0.005 mole per liter solution, it will have conductivity of 7.4 millisiemens per meter, 0.001 14.7 millisiemens per meter, and so on. 0.02 will have 277 millisiemens per meter, 0.1 will have 1290 millisiemens per meter. This is given, this table is given in the code. With the help of we know the molarity of the solution, we can find out how much will be the electrical conductivity of this solution for the calibrating our equipment or apparatus. So once we prepare the molarity standard solution, with this we should first calibrate our conductivity meter. We should clean the electrode thoroughly. We should and wipe excess water carefully using tissue paper or lint-free cloth. After drying it, we take the solution, stir it well, and in that again immerse the conductivity meter, and the conductivity meter, when it is applied, it gives the reading. For the standard solution, it has given 1413 microsiemens per centimeter. So now our equipment is in good order. We can go for taking the field solution. Similarly, we take the field solution maintained at 25 degree centigrade plus minus 1 degree centigrade. In that, we take the measurement and record the electrical conductivity of that water. On the temperature in the field or in the laboratory is not proper, then we should apply the temperature correction given in class 7.2 of the IS 3025. We can take a field observation sheet to understand well. We have collected Ganga River water. Sample location Varanasi Ghat. For the example, temperature for that solution was 25 degrees centigrade. Date of collection 14/06/2026. All this once we collect the sample as per IS 3025 part 1, and then we should label it with the time, date, temperature, etc., and bring back it to the laboratory. Or if we are testing in the field having the equipment, we should test in the at the field. Then we should record the ambient temperature as well as the temperature of the water for applying the corrections. Then first we calibrated our equipment with the standard solution of 0.01 molarity of KCl, and it has given 1413. Hence our equipment is ready for the, it is in good condition, ready for the test. Then at 25 degrees centigrade, sample number 1 we tested, we found 452 microsiemens per centimeter. Sample number 2 458 microsiemens per centimeter. 25 degrees centigrade, sample number 3 449 microsiemens 449 microsiemens per centimeter. We get the average 453 microsiemens per centimeter. So our observation is over. Now we should compare with the standard. What is standard electrical conductivity to categorize our water sample, whether it is excellent, good, fair, or in poor condition. So for this, if it is electrical conductivity measured is less than 250, the water sample what we obtained from the field, the source is very excellent. Then 250 to 750, it is in good condition. 750 to 2250, it is in fair condition. 2250, 5000 poor, and it is greater than 5000 unsuitable. The observed conductivity of approximately 453 microsiemens per centimeter indicate good quality river water with moderate dissolved mineral content. So this can, if it is 453, it comes in this category. The water is of good quality. It can be utilized for the purpose of drinking. temperature correction. If measurement at 25 degrees centigrade plus minus 1 degree centigrade is not possible, then measure the conductivity at field temperature, whatever field temperature is there, and apply the correction to obtain value as per class 7.2 of the IS 3025. Then we should apply the correction to find out the actual conductivity of water. So thanking you. The next we will be what is pH of pH we will be studying.